This is Richard Cuselak with GMC Stream, and we're very lucky. We're at the Space Symposium, and we have a great representative of the U.S. Naval Research Laboratory with us. I'm going to let him introduce himself. Primarily, we're going to talk a little bit about the laboratory, a little history. It's really amazing that they're doing a lot of work in space, but perhaps not as well known. So this is kind of a casual discussion, he and I. And so let me let him introduce himself.
Okay, well, thanks, Richard. My name is Chad Largis. I work at the Naval Research Laboratory in Washington, D.C., and I'm specifically in the Naval Center for Space Technology, which is one of our directorates there that focuses on space research and development. My role is the military deputy there for the director of the Naval Center for Space Technology. My career initially started as an EA-6B naval flight officer, but I got back to my engineering degree in aerospace, and I'm enjoying my time now at the lab.
Oh, great! Well, can you give us a little bit more insight? I mean, you and I had a great conversation the other day, and I was really impressed with your overall knowledge of some of the activities that the Navy is doing, primarily the Navy in space. And I don't think a lot of people, at least in my domain, know the amount of work that the Navy is doing in this area of space.
Sure. I was one of those people before I got to the lab, but as I got there, the impressive legacy that the Naval Research Lab has had. When we go back to the beginning of our nation in space, started with the Vanguard project, and that was at Naval Research Lab right there in Washington, D.C., where it was built. And so they built it and launched it. Unfortunately, there was another nation that beat us into space, otherwise Vanguard would have been our first spacecraft. But the technology and the expertise that continued at the research lab kept the Navy involved in spacecraft engineering and space systems development. Unfortunately, President Eisenhower liked it so much, he took a majority of our folks and created another organization known as NASA.
Oh, wow. Then that is really an interesting point.
Yeah.
Extremely important. I don't think a lot of people know about that.
Yeah. But the folks that stayed behind continued in the legacy. We had a ground station that was designed to control Vanguard and to monitor it, and that's still in use by us today down at Blossom Point in southern Maryland. So we have expertise that ranges from design. We can conceptualize it, build it, integrate it, test it through all the environmental testing facilities, get everything ready right up until launch, and we do it all right there in-house with our own team of experts and engineers at the research lab.
So tell me a little bit more about the launch activity. That's something, of course, that we don't know too much about in the sense of the overall naval requirement to have command and control, but also to protect the naval fleets.
So the Navy is one of the biggest users of space because of their mission is out on 70% of the Earth is covered by water, so they need to be able to communicate, control data back and forth. But the Air Force is the executive agent for space, or now the principal DoD space advisor, as they call it. The Air Force has the budget and the authority to do it, but the Navy realized the importance of it, so they continue to have spacecraft, or they continue to support spacecraft development from other people. At the Naval Research Lab, we have the unique capability of, we're the Navy's corporate research laboratory, so we focus predominantly on that, but we can support the Air Force, the intelligence community, other industries in space research and development, and we continue to do that. Since we started in space back in the late 50s, we have developed and had launched 100 satellites, over 38 launches. Some of them, a lot of people are familiar with. Vanguard obviously was the first one. Another one was called GRAB. It was a little spherical satellite that went up to do atmospheric
It's kind of like a
research.
micro, like we're talking about today, micro satellites.
Like micro satellites.
Or,
back in the day, they were like grapefruit satellites, we called them.
Okay.
But what wasn't known at the time, because it was classified, was a little reconnaissance sensor inside. So GRAB became the nation's first reconnaissance satellite.
Wow.
And then there were follow-ons to that. Another big one that people don't realize was a satellite called Timation. We realized that there needs to be a standard time distributed around the globe so that everybody could use it, and the best way to do that was from space. So the Naval Research Lab built this satellite, which became the prototype that turned into a constellation now known as GPS that the Air Force fielded.
That is, again, I think that that point you just made is is remarkable to me, and I think remarkable to a lot of people, because as we well know, GPS is so important not only for consumers but also for military use. And can you kind of elongate a little bit about the GPS during this period?
GPS, we obviously weren't the only ones in it, but what we
Sure.
had was a timation branch that
Okay.
did a lot of the work, and we still have that today. They do positioning, navigation, and timing, or PNT as it's known.
Okay.
And there is constant research done on how you can improve the accuracy of clocks, atomic clocks, different types of times, getting it down to accuracies at the picosecond level, and how do you distribute that. So that was where GPS started. At the lab, our main mission is to do prototypes and these one-off research and development. We don't get into the building of constellations or the mass productions.
Right. Okay.
What we do is come up with an idea that's innovative, we prove it works, and then we transition it over to industry.
Oh,
So our role was the beginning of GPS. We transitioned it over to the Air Force, and they took the run with it and then populated the constellation that we have today. But it was thanks to the knowledge of the scientists and engineers at NRL that got that concept moving.
Well, I really like what you just said about the fact is that the innovation actually was then, given to another military agency, but also to the consumer, to
Sure.
private business. I don't think I've ever heard that before, where we have a military organization that actually is working on innovative things, but also then allowing that technology to create productivity in the business area. I think that's really fabulous. It's something I haven't heard before.
Yeah. We are what's called a working capital fund organization.
Okay.
So we don't have any appropriated funds. We don't
Okay.
have a budget per se. Some folks like to call us the Navy's coin-operated laboratory.
Okay.
Even though we're the corporate research laboratory, which we focus on the Navy, but whatever customers need us to do,
Right.
we have the ability to do that. And the challenge to our researchers is to find a way to find that application for their research,
Okay.
get it into some customer's hands, whether it's the government, whether it's the
Sure.
Navy, and then it can be something DoD benefits from, or it can be something
Sure.
that industry and civilization benefits from. There's been many research efforts outside of space that NRL has had a legacy in, and that's sonar was the first one. The lab was created back in 1916 was when the concept was started. There was a sinking of a British cruise liner called the Lusitania, and over 100 people had died, and there was a lot of concern in the folks in our nation, to include Thomas Edison, who wrote an op-ed stating that, he sent it to the Secretary of the Navy, Josephus Daniels, saying we should create some sort of federal laboratory that can make sure our weapon systems are ahead of our enemies. And so Secretary of the Navy agreed with that, created a naval consulting board, brought in a lot of the key personnel. Unfortunately, World War I got in the way, so we didn't break ground until 1923. There in Bellevue, just on the southern part of Washington, D.C., and that's where we've been since. So ironically, one of the first things that we developed at the research laboratory was sonar.
Wow.
Later on, we developed some radar. We have done all sorts of basic chemistry. One of the more recent things we've developed and given to the Navy is the material that's on top of the flight decks to
On
be able
carriers?
to, on the carrier, the non-skid, because it has a longer capacity to not burn, to have longer life, not flake. So
Right.
what's unique and why the Naval Research Laboratory is still around and why it's necessary is because when you have industry do things for the military, they have the capability of doing R&D,
Sure.
research and development. But oftentimes what's not beneficial for them economically is the basic advanced science that needs to be done. And then that'll turn into projects that can push prototypes or further advanced research and development concepts that will then turn into a weapon system or a platform that the
Sure.
operator can use. So a lot of our effort at the lab is focused on that basic and advanced science. In the Naval Center for Space Technology, where I'm the military deputy, there's not much basic and advanced science. We get more into the developmental efforts and the prototyping. One of the other satellites that I think I mentioned to you before was called Clementine, and that was the first satellite that went and mapped the entire surface of the moon. And from that, we tested a capability of photography and take an imagery of the moon that was used later in other systems. But it also found evidence of water under the surface of the moon, or ice under the surface of the moon.
Yeah, that's becoming a very important thing as people are talking about the moon as a kind of a stepping stone, if you will, to Mars. And matter of fact, one of the landings is going to be in that particular area where they believe there's water in that. I forget the name of it, but I'm sure you know it better than I do.
Thanks to Clementine, we realized it was there. So.
Wow, that's really amazing. You know, I'm going to go back to something that that I believe is truly important, and that is that you're doing so many great things in the innovative sphere, and it's amazing that you're not getting the type of funding that you need to do even more. I don't know how large is the staff there. Can you tell us a little bit?
The
about
lab
that?
itself has about anywhere from 2,500 to 3,000
Oh
people.
my gosh!
We're headquartered in D.C. We have facilities down in Key West. They focus a lot on corrosion research. Ironically, the sea state down there and the chemistry of the water is conducive for that type of study. We have facilities down in southern Mississippi. We have them in Monterey, California, that do oceanographic and atmospheric type research. And then around D.C., we have outlying facilities, like that Blossom Point tracking facility I mentioned. We have one on the Chesapeake Bay. We have another one down in Quantico, the Midway Research Center. A lot of those are more in our space portfolio and space research area. And then we have satellites scattered around the country that can do atmospheric testing and command and control of developmental satellites and things like that.
Well, you know, again, I want to get back to the point of if anybody's hearing us, you know, I think the lab definitely needs a little bit more funding. It sounds like you're, of course, being very productive with very limited resources, and I think that should be changed. You know?
Sure. We have about a $1.2 billion a year budget.
Yeah.
Some of that comes from we work for the Chief of Naval Research, who has a staff, the Office of Naval Research, that does funding for whatever type of science and research needs to be done. They fund universities, small businesses, but they also give us some funds, about maybe 20% of what we get each year is from them. And then at the lab, we can parse that out to individual, what we call new starts, so proposals for those basic and advanced science work. And we can determine amongst ourselves and what the Navy needs, which ones are important. So there's funding there, but the rest of it is all from outside customers. And that's part of the reason why we're able to stay around, is because we're able to sustain our own infrastructure through that.
Well, you know, what I like about it, too, I think the business model is, you know, if we talk about, we're looking at business models that they've been talking about in government for a long time, but the lab is a very good example of having a business case, a business model, and having the types of results that result in funds coming back to you. So I think that is really extremely credible, and perhaps more of some of the other services should take note of it. Well, you know, I wanted to keep this very brief, of course, and I want to thank you very much for spending some time, Commanders. Do you have any, ending comments, perhaps?
No, I guess the biggest thing I would have, in my time, it's been just over 3 years, I've realized that the hidden secret and the legacy of the Naval Research Lab, particularly in space, is missed on a lot of ears. And so getting the word out and the fact that we are there, we're ready, we're constantly doing new innovation, new ideas that span the full spectrum of anything in space, whether it's space science, whether it's satellite control, whether it's building, like I said, everything except for the launch. And I doubt we'll ever get the opportunity to build a launch facility in Washington, D.C., but
I think, well, and maybe you can have some help down in the Cape.
Well, there you go.
Give you a launch area. Well, again, I want to thank you very much. It's been extremely pleasurable. This is knowledge that I hope that gets disseminated, and people should realize that the U.S. Navy is out there as well. Not only innovating, but also protecting the nation. So thank you very much.
Thank you very much, Richard.